Okay, this will be our last video on scikit-learn pipelines. So in certain cases, we may want to apply different pre-processing steps based on the data itself. So what do I mean by that? I mean, most commonly, we want to apply different pre-processing if the data is numeric or if it's categorical. So let's look at how we could actually do that. Again, what I do is just generate some random data, make that into a train test split, and then you've seen this before where we call this get pipeline function, and that we can just pass in whatever model we want to be at the end of the pipeline. And then when we're training our model with HyperOpt, we are actually optimizing our entire pipeline. So let's look at this pipeline. And we can see this one is much more complex than the ones we've looked at in the past. In fact, in the last video, we gave a quick preview of this, but here I wanted to go more in depth on what this pipeline is actually doing. I'm not going to review each individual step, but if you kind of take a look at it, you can see that we have function transformers, we have some custom classes, we have some off-the-shelf scikit-learn classes in here as well. You can see that there's a lot going on, and if you scroll up to the top of this file, you can see all the different classes that we're importing from scikit-learn. Our forest param grid here is at the top, and then you can see the functions that we're using in the function transformers, and then our custom classes as well. So when digging deeper into this pipeline, I'm actually going to start at the bottom. So we can see that we have our model. We apply something to our entire data set called a variance threshold, which basically just removes data that has very little variance to it. And that comes directly from scikit-learn. And then the step before that is our preprocessor. Okay, well, what is our preprocessor? This leverages something called a ColumnTransformer, which is how we can apply different pre-processing based on the data itself. So most commonly, this will be a numeric transformer and a categorical transformer. So the numeric transformer is applied to number data, and the categorical transformer is applied to non-number data. So you could actually do something that's a little bit more flexible. So you could say that, for example, I have 10 numeric features. I want 5 to go through one type of pre-processing pipeline, and then the other 5 to go through another. And then I have 12 categorical variables, and I want those to all go through a single separate pre-processing pipeline. So you can be a little bit more creative with this, but most commonly it will be I want different pre-processing for numeric and non-numeric data. So we can see that these just reference these transformers up here. And when I say these, I mean the numeric transformer and the categorical transformer. Those are just referencing these items here. So for our numeric transformer, we have a function transformer that's clipping features. We take a logarithm. This is how we are actually doing it's not really dummy coding in this case because we have numeric data, but the dict vectorizer is a way where we can create a representation of our data that will help us in a production environment. I won't go too much in depth in that, but there could be cases where, for example, if we see a brand new category level in production that we've not trained on, and this is something that can happen if we don't have as much control of the data generating environment, the dict vectorizer can kind of seamlessly handle those types of situations. So that's where that's getting applied and why that's getting applied. And then we're applying an imputer. So with numeric data, imputing the mean is fine, but if we have categorical data, well, we don't want to impute the mean. That doesn't really make as much sense, if you will. And then we talked about the select percentile. So there's a specific type of algorithm that we want to use for numeric data, which is different from the algorithm that we might want to use for categorical data. Again, I actually define a function transformer to fill missing values. So how we would want to fill missing values for categorical data is different than how we would want to do it for numeric data. So we can see that we're able to bifurcate our pre-processing based on the type of data, because the types of decisions we make could be contingent on, is this numeric data, is this categorical data? And in certain cases, you want kind of stark differences in how you do this, and certain types of pre-processing for numeric data just makes no sense for categorical data, and vice versa. So really the way to do that is with the column transformer. So we'll run this. You're going to see some warning messages here. Those are just kind of random warnings, if you will, dealing with the feature selection. This is just because I'm generating very random data. So I believe it's the feature selector can't really converge. Yeah, no features were selected. It's either too noisy or too strict. So it gets a little bit messy in this case because it's just totally random data. So in that case, that means the feature selector is working and saying that it's too noisy. I don't know how to actually fit this. But what's most important is that we do actually exit with an exit code 0. Our model trained, we can see that there is a loss score here. So with all of this pre-processing, we were able to run this without a hitch, and really the only issue is that we're just generating random data. So again, column transformer can definitely be something that is very powerful, and when you're using these scikit-learn pipelines, stuffing in as much pre-processing to them as you possibly can helps prevent feature leakage. It helps ensure that your training environment is replicated very well when you're in production. So there just are a lot of advantages to using scikit-learn pipelines, and in a lot of advanced use cases or anything that's non-trivial, something like a column transformer can make a big difference.